right, Heidi Ho neighbors, Mrs. Smith here again. We are in lesson 4-6, absolute value equations and inequalities. I know this whole chapter is about inequalities, but we need to talk about equations first, so we're going to do that. Secondly, I'm going to tell you that this is the toughest lesson in this chapter, and students really struggle with this lesson, so you really need to tune in and pay attention. All right, so let's talk about some equations first, because we need to get some background information before we delve into actually doing the equations and inequalities. Okay, so we're going to go ahead and split this up because all absolute values yield two answers. There's usually two things that work. Like, for instance, if I wrote this again and I can put in two different things to make this come true. I could put in 7 for x. So I just replaced x with 7. And if I take the absolute value of 7, 7 equals 7. True? That's true. But could I also put in negative 7? Negative 7. Well, let's see. If I put in negative 7, let me make my negative sign a little bit bigger. I take the absolute value of negative 7, it's 7. And 7 equals 7. And again, it's true. So that itself kind of makes absolute values a little unique. They're a little different. So please write this down. It says solving absolute value equations. And this is the mathematical language that kind of goes behind this. And I think it is so very important that you guys know how to read mathematical language. So mathematical language, please write this down, says to solve an equation, in the form absolute value of A equals B, where A represents a variable expression and B is greater than 0, solve A equals B and A equals negative B. Okay, so, excuse me, I'm going to kind of highlight here just to bring out some things. So this is mathematical language. Eventually, you're probably going to have to be on your own someday, reading mathematical language all on your own. And so one of my jobs this year is to kind of teach you how to dissect it, how to break it apart so you can kind of understand it. So it says to solve an equation in the form of the absolute value of A equals B. So that's what we were doing right up here. Absolute value of x equals 7, okay? Where A represents a variable expression. It happened to be just a number here, but it could be a variable expression, or it happened to be just a variable, I guess. And then B is greater than 0. So B is greater than 0 is going to come into play real soon. They say to solve A equals B and A equals negative B. So what they're saying is just like we had up here, and you had a 7 and a negative 7, because both answers work, when you set this up, you have to have a B and a negative B, because both answers work. Absolute value yields two answers, a positive and a negative, because they both work. Okay, so that's going to come into play. Secondly, I'd like you to write down this note. This is going to be very important. Note, you must isolate, and I'm going to write it in great big capital letters so you remember the absolute value, and I'm even going to underline it, the absolute value sign first, which means get rid of everything, and then I'm going to write it in huge letters, outside. Obviously, you know, I see kids make that mistake. Before, and I'm going to write that in fairly big letters, setting it equal to a positive and negative number. Okay, so let me pick up my highlighter. I'm going to highlight a few things that is going to be really important. So note, you must isolate first, and that means get rid of everything outside before setting it equal to a positive and negative number. So that's going to be really, really important, and I see lots of students make that mistake. So definitely wanted to point that out, and now it's loud and proud and green up there. So therefore, hopefully you won't make that same mistake that other students have made. All right, so example. Here we go. Number 1 is the absolute value of y equals 4. Okay, very similar to what we started with right up here. So what we're going to do is just like here, we split it into 2 answers, and that's what we're going to do here, because it says you got to set it up to the positive and to the negative right there in the mathematical language. So that means, and when I do that, I'm going to drop the absolute value signs, and I'm going to do y equals 4, because if you noticed, there's no absolute value signs. They went from an absolute value sign here to no absolute value sign up here, and no absolute value sign up here. So they have y equals 4 and y equals negative 4. And that's our answer. You have 2 answers, y equals 4 and y equals negative 4. Okay? So let's check and see if that works. So let's check. So we put in 4, and we're going to put in a negative 4. So 4 equals 4, and negative 4 equals 4. Let's see. If I take the absolute value of 4, it's 4. So 4 equals 4. That's a yes. Negative 4 equals 4. Negative 4, take the absolute value is 4, equals 4, and that's a yes. So it checks out. Okay? So now, that's the most simplistic example I can give you. So let's take it up a notch. Now it's the absolute value of a minus 3 equals 5. The absolute value of a minus 3 equals 5. Now, this says to isolate, get rid of everything outside. So what I need to do is get rid of this negative 3. And I do it just like as if I were doing a problem. So an equation like normal. So I'm going to add 3 first. Okay, so that leaves me the absolute value of a equals 5 plus 3, which is 8. So now I've gotten rid of everything on the outside. Now I can set it equal to a positive and negative number. And it's not much different than I had up here. So I split it up. I drop the absolute value signs, and I say a equals 8 and a equals negative 8. Okay, so let's go ahead and do our check step just like before. So I have the absolute value minus 3 equals 5, and then I have the other one I have to plug in, absolute value minus 3 equals 5. So I'm going to plug in 8, and I'm going to plug in negative 8, because those were my answers that I came up with. So absolute value of 8 is 8. 8 minus 3 is 5. 8 minus 3, 5 equals 5. Yep, it checks out. Negative 8, take the absolute value, which would be 8. 8 minus 3 equals 5. 5 equals 5, and yes, it checks out. Okay, now let's do number 3. Because I think what you're thinking, oh, well, this is pretty easy. You just kind of get 8 and negative 8, but that doesn't always happen. And let me show you the next example. So the next example is 2p plus 5 is equal to 11. 2p plus 5 equals equal to 11. Now, do I have anything on the outside of this absolute value? And the answer is no. So I am ready to set it equal to a positive and negative number, because there's nothing on the outside to get rid of. So I'm going to split it up. When I split it up and I set it equal, I drop the absolute value sign. So I have 2p plus 5 equals 11. And then notice what happens. Remember how I said 8 and negative 8? So now I'm going to do 2p plus 5 equals negative 11. So I changed that part to a negative 11 there. Okay, so be very, very careful. This is definitely something that's got a lot of rules to it, so you got to pay attention. Now I have two-step equations that I need to solve. So I'm going to subtract 5 and subtract 5. So that gives me 2p equals 6, divide by 2, and divide by 2, and p is equal to 3. That's one solution. And now let's do this one. I'm going to subtract 5, and I'm going to subtract 5, and I have 2p equals negative 11 minus 5, which would be negative 16. Divide by 2, and p is equal to negative 8. So here I had 4 and negative 4, 8 and negative 8. Here I have 3 and negative 8. So totally two different answers. Or two different numbers, I guess. So I had two different answers up here as well, but totally two different numbers. So don't fall into the category that everything is going to be 4 and negative 4, 8 and negative 8, 7 and negative 7. It's not. So be careful. And you think, geez, calm down, Mrs. Smith. Well, I'm just telling you because that's the mistake I see all the time. So be careful. Be careful. All right, so let's do our check step like we were doing before, just to see, are we on the right track? So I have 2, and then instead of p coming to the beginning, I'm going to put in 3 because that was one of my solutions, plus 5 equals 11, and then I'm going to put in my other one, 2, and instead of 3, my other solution was negative 8, and then plus 5 equals 11. So now let's solve. 2 times 3, it's order of operations, so I'm going to multiply first, is 6, and 6 plus 5 inside equals 11. 6 plus 5 is 11, so be careful because those are absolute value signs, kind of look all the same here. And then take the absolute value of 11, and 11 equals 11, and yes, it checks out. Okay, so let's do this. Order of operations says multiply first, so 2 times negative 8 is negative 16, plus 5 equals 11. Negative 16 plus 5 is negative 11 equals 11. The absolute value of negative 11 is 11. And yes, it checks out. So I actually had two different answers. I have a 3 and I have a negative 8. Okay, so moving on. We need to talk about a couple more examples. So number 4. Negative 5.5 equals the absolute value of x plus 2. Notice I flipped what side the absolute value is on. Does not mean anything different. Next, what I have to do is I have to isolate the absolute value. It's already isolated. It's by itself. So I can immediately split it up into 2. Now, the first thing really happens is I just really copy all of this without the absolute value sign. So negative 5.5 equals x plus 2. And then I drop it, and then it would be positive 5.5 equals x plus 2. So I hope you realize that's what I'm always doing. I'm setting it up to the positive and to the negative once I have it isolated. All right, so now I go ahead and solve. So I'm going to subtract 2 and subtract 2. So that is going to be negative 7.5 equals x. And here I'm going to subtract 2 and subtract 2. And I have 3.5 equals x. Again, two different answers, so that's perfectly fine. So now I'm going to do my check step. So I put in negative 5.5 equals absolute value, and I put in the first one, which was negative 7.5, and then plus 2, and I solve. So negative 5.5 equals, what's negative 7.5 plus 2? Negative 7.5 plus 2 would be negative 5.5. Take the absolute value of negative 5.5, and I have 5.5. Uh-oh. It says it should be equal to negative. Right here, see that negative sign? Is it? No, that doesn't work. Well, let's see if my other one works. So I've got negative 5.5 equals absolute value. Now I'm going to plug in 3.5, my other solution. Whoops, I didn't mean to do that. Plus 2. I'll just make it a big plus 2. All right, so negative 5.5 equals, what's 3.5 plus 2? That's an absolute value of 5.5. Take the absolute value of 5.5, so I have negative 5.5 equals 5.5. Uh-oh, does that work? Again, the answer is no. Oh no, what's going on? I thought I had it down. Well, let me go back to the definition again. And let me go back to this part right here. How about this part right here? It says B has to be greater than 0. Do you see B right here? Do you see B? B has to be greater than 0. Let's go back to that example. Right here. Here's my B. I know I flipped it around, but that's my B. Is B greater than 0? The answer is no. B is not greater than 0. So immediately, if B is not greater than 0 and this is isolated, I can stop right there and write no solution, because it's never going to follow it won't follow the rules, and B has to be greater than 0. So technically, I want you guys to be smart. Once you isolate, if you see B is negative, you don't have to do all of this stuff here. You can just write no solution. So look for those patterns. Look for those things that you need to know. So let's do number 5. We just have a couple more we're going to do. Number 5, negative 4, absolute value of k equals 12. Now, remember, you have to always isolate first. These are being multiplied. So to get rid of that negative 4, I need to divide. And of course, what I do to one side, I do to the other to keep it balanced. So that leaves you the absolute value of k equals 12 divided by negative 4. 12 divided by negative 4 is negative 3. Negative 3. This is isolated and it's negative 3. Are you screaming at the screen? Are you telling me, Mrs. Smith, stop, stop. I know that this is a negative after I isolate. So this indeed is, dun, da, 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 no solution. And I'm done. But it's after you isolate, and if it's negative, it's no solution. All right, let's try number 6. Absolute value of C minus 10 equals negative 3. Now you're thinking, oh, it's going to be no solution. I haven't isolated, so I have to isolate first. So I'm going to add 10 to both sides. Isolate first. And that leaves you the absolute value of C equals what's negative 3 plus 10. Negative 3 plus 10 is 7. Oh boy, guess what? It's positive now. So I need to split it up. So that would be C equals 7 and C equals negative 7. Okay, so you take it and set it equal to the positive and to the negative, and you're done. Okay, number 7, one more, number 7. Negative 2, absolute value of x plus 3 equals 10. So you're thinking, yep, I'm good to go. It's a positive. Nope, need to isolate first. So these are being multiplied, so I need to divide by negative 2. And when I divide by negative 2, that leaves me the absolute value of x plus 3 equals 10 divided by negative 2, which is negative 5. Ooh, did you see it? It's isolated and I have a negative, so stop right there and write no solution. All right, those are absolute value inequalities. Try your luck at doing them.